Hey everybody, today's lesson is on completing the square for ellipses. And there's a couple things I want to point out to you before we begin is that number one, how can you tell by looking at example number one that it's an ellipse and not a circle? So we've only mentioned this briefly in our last chapter when we talked about circles, but the fact that this number and this number are different, meaning the x squared coefficient and the y squared coefficient are different, that's what's going to form your elliptical shape, and it's not going to be symmetric all the way around, therefore it's not a circle. So just keep that in mind before we begin. You should be able to recognize, without having to do all this completing the square stuff, what kind of a shape it is before you even begin. Okay, so what we're going to do when we complete the square is we're going to start like normal. We're going to move our constant term over to the other side. And I'm also going to group my x terms together, and I'm going to group my y terms together. And so the reason I'm going to do that is because I'm going to complete the squares with the x's and with the y's, just like we did for circles. So I'm just going to rewrite this to get it set up and ready to go. 25x squared minus 150x. So I'm just rearranging a little bit. And then I'm going to put the 111 onto the right hand side. Okay? And so now you know that to complete the square, the coefficient of the squared term has to be 1. So I need to do a little bit of factoring out. I'm also going to add my blanks to each side all at the same time. So this is going to look like this. I'm going to take out the 25 from both of the x terms. That gives me 6x plus blank. And that's because I took the 25 out. And then what I'm also going to do is take out the 16 from the y's. That gives me y squared minus 4y. And on the right, that leaves me 111 plus blank plus blank. So remember, whatever you add to one side, you have to add to the other. And we are also going to make sure that we remember to keep the equations balanced. So what I'm going to do from here is I'm going to go ahead and complete the square, take half of -6, which is -3, and then square it, which gives me 9. Make sure you multiply that 9 by that 25 before you add it to the other side. So that actually gives us 25 times 9, which is 225. So make sure that you're multiplying by that coefficient in front, okay? And same thing over here. I'm going to do the half of -4, which is -2, and then square it, which gives me 4. And make sure you take your 4 times your 16, which gives you 64 on the right, okay? So that's very similar to circles, except we actually factored out a coefficient from the x squared and the y squared. So that's what forms the ellipse, actually. So I'm going to factor this. I'm going to keep the 25 in front, and that means that I have x minus 3 squared. And I have 16 in front of the y's, and that's y minus 2 squared. And combining all of these like terms over here actually simplifies pretty nicely to 400. Okay, so something pretty important here. One thing that we need to remember is if you go back up to the first page of the ellipse part, when we did the standard form equation, that needs to be equal to 1, if you remember, for all the standard form for an ellipse equation. So what I need to do in order to make that a 1 is I need to divide every single thing by 400. And I'm just going to reduce all of my fractions individually. Okay, so the whole purpose of that is that now that it equals 1 on the right hand side. So now I'm just going to reduce 25 over 400, which gives me 1 over 16, or x minus 3 squared over 16. And then when I reduce 16 over 400, it actually reduces to 25, or 1 over 25. So y minus 2 squared over 25. Okay, so there is our standard form for the ellipse. So remember that the center is going to be at 3, 2. And then remember from yesterday, I'm going to go left and right 4, up and down 5. I'll actually do that real quick. I'll just say left and right 4. And this 25 means up and down 5. And that's going to form my ellipse. And make sure that it has to equal 1 on the right hand side. So that's why we divided everything by 400. Okay, that's example number 1. Look, it looks like a lot of math right there. It's a lot of, it can get kind of messy. So you got to keep everything straight, nice and lined up. Alright, let's try the second one. What I'm going to do is move over the 23, and I'm going to group my x terms together and my y terms together. I'm also going to factor that out and add a blank all at one time, you guys, so stay with me. I'm going to take out the 5 from the x squared and from the 50x, so that's going to give me 10x plus blank. And from the y's, I'm going to take out the 3. Y squared plus 8y plus something. It's going to be negative 23 plus blank plus blank. Okay, now we're going to go ahead and complete the square, just like we did in the last one. What I'm going to do for the x's, I'm going to take half of 10, which is 5, and square it, which gives me 25. Make sure you do your 25 times your 5, you guys. 125 gets added to the right. And then half of 8 is 4, and then when you square it, you get 16. Take your 16 times your 3, and that gives you 48. Okay, so almost done. Now I've just got to clean everything up, do a little bit of factoring, and then divide at the end. So when I factor this, I get x plus 5. Factor this side, y plus 4. Combining like terms on the right gives me 150. And then all I have to do is make sure that equation equals 1 when you're finished. So we're going to divide everything by 150. Divide by 150, divide by 150. And that's going to reduce all of your fractions evenly. It's going to give me x plus 5 squared over 30. And then y plus 4 squared over 50 equals 1. Make sure that equation equals 1 when you're finished. That's the standard form. Okay? And yeah, I know those numbers aren't perfect squares, and a lot of times they won't be perfect squares. That's okay. We're just going to get decimal approximations when we graph them. So the 30 and the 50, you'll just get as close to a decimal as you can. Alright, so we've got 2 left. This one, the constant term is already moved over, and my x's and my y's are already grouped together, so it's a little bit easier. So I'm going to factor out the 7 from the x's. I'm going to factor out the 4 from the y's. I have negative 4 plus something plus something. Okay, so go ahead, quickly complete the square. I'm going to start by taking half of negative 4, which is negative 2. And then square it, which gives me 4. 4 times 7 is 28 on the right. Make sure you're multiplying by that coefficient. Half of 2 gives me 1. Squared is 1. 1 times 4 is 4. Okay, now we've got to factor and clean this up just a little bit. And then I've got 4 here, y plus 1, quantity squared. Notice how just the 4's cancel on this side, so we just have 28. And then all I have to do is just divide every single thing by 28. So I've got x minus 2 squared over 4, y plus 1 squared over 7 equals 1. So for the x's, we would go left and right 2 after we plotted the center. But the 7 doesn't square root, as you know. That's okay. They won't always square root. You'll just get a decimal approximation. It's going to be somewhere between 2 and 3, and that makes it a vertical ellipse since the y radius is a little bit bigger. Okay, if you want to, go ahead, pause the video, see if you can work through number 4 on your own, and then just check your answer, and then you guys are done. We'll talk some more about this in class tomorrow. Go ahead, pause, see if you can work it out, and then I'll keep talking and going through all the step by step, but see if you can do it on your own. So what I'm going to do is group my x's together, group my y's together, and move the 9 over. I'm going to do that all at once and add my blanks in and factor out the coefficient. So I'm taking a 3 out of the x squared term and also out of the 12x term, and that's why I got 4. So just make sure I'm doing a little bit of rearranging here. I've got 3 y squared minus 2y plus blank. Negative 9 plus blank plus blank. Go ahead, complete the square really quickly. Half of 4 is 2, squared is 4. 4 times 3 is 12. Half of negative 2 is negative 1, squared is 1. 1 times 3 is 3. So I've got a factor here. X plus 2 quantity squared. Y minus 1 quantity squared. And when I combine like terms on the right, I just end up with 6. Okay, so we're going to divide everything by 6. Divide by 6, divide by 6, divide by 6. This means that I have x plus 2 quantity squared plus y minus 1 quantity squared. Those are both over 2 because 3 over 6 reduces to 1 over 2. Okay, and pop quiz. This is not an ellipse. Why? You should be thinking because the 2's are the same number underneath, doesn't that mean you go left and right the same number as up and down, which is what makes it a circle? So this is actually a circle. Okay, so technically, if we were going to write this in circle standard form, then I shouldn't have divided everything by 6. What I need to do is, could you tell what the radius is? Like, so kind of think about it for a second and see if you can figure out what the radius is going to be of this circle. So if you just multiply every single part by 2, times 2 here, times 2 here, times 2 here, to write this thing in standard form, think back to when we learned circles. Circles don't have division, like they don't have any numbers in the denominator, right? So the standard form equation of the circle is actually x plus 2 squared plus y minus 1 squared equals 2. So it's actually a circle. So just kind of be thinking about, like, we haven't forgotten all the shapes that we did before we learned the ellipses, okay? The reason that I knew this was a circle is because I went left and right and up and down both square root of 2. And if you look up at the original problem, kind of cool thing about that one is, remember how I started the video is by asking how do we know that it's an ellipse? Well, look at the x squared term coefficients here. They're both 3. That means it's symmetrical all the way around. That also gives you a clue that this is actually a circle. Okay, and this is the standard form equation of a circle. It doesn't have any fractions in it. It's not equal to 1 unless the radius is 1. Okay, so just kind of a little hard one to end on. Bring some questions to class tomorrow. Thanks for listening. See you later.